You watching Srikanth Ideal Chemistry. So in this video we are discussing about next application of mesomeric effect, that is a stability of carbanion. Generally the stability of carbanion is directly proportional to minus M effect, minus I effect and extents of resonance, and inversely proportional to plus M effect and plus I effect. So stability is directly proportional to minus M effect, minus I effect and inversely proportional to plus M effect and plus I effect. At the same time, the stability of carbanion is directly proportional to extent of resonance. Extent of resonance. So here we just see some examples. Okay students, this is example 1. So in this example, here we have 3 compounds. One is benzyl carbanion, here triphenyl carbanion, and here diphenyl carbanion is present. So here the stability of carbanion is directly proportional to extent of resonance. Based on this, these compound can form the 4 resonating structures. It can form 10 resonating structures. It can form 7 resonating structures. Based on that, the order of stability of carbanions is in order of second structure having more resonating structures. So second structure is more stable than third one, and first structure is at last due to less number of resonating structures. Okay, next we go for the second example. So in this second example, here we have minus. So in this second example, so here we have 3 type of compounds. Again we have here the negative charge can be shows the conjugation with whether these carbon. In that situation, these pi electrons are shifting towards to these oxygen. Suppose if this negative charge can shifting as to here as a pi electrons, and these pi electrons are shifting towards to oxygen as a lone pi electrons. So here resonance can be possible. 2 conjugate structures. Here conjugation is present. Conjugation. So 2 conjugation structures can be possible, or conjugation can be explained in 2 ways. When it comes to here, so here these negative charge shifting as a pi electrons towards here, and these pi electrons shifting towards the oxygen. So here also conjugation is present, but the conjugation present in only one way. So when it comes to here also the negative charge shifting towards the pi electrons here, and these pi electrons are shifting towards the oxygen. Here also conjugation is present, and one conjugation, number of conjugate structures 1, and this carbanion is attached to the plus I group. So the plus I group can be destabilize the stability of carbanion. So due to that, in this first structure is more stable. Why? Because due to formation of 2 conjugate structures. So first structure is more stable. After first, in the second and third structure, both are can form the one conjugate structure. But here in the third structure, the carbanion attached to the plus I group. The plus I group can destabilize the stability. So second structure is more stable than a third structure. This is about the second example. Next, when you go for third example, here we have the 5 structures. So in this 5 structure, here oxygen and nitrogen atoms are present in the ring. So it is an example for heterocyclic compounds. So here oxygen having negative charge, so it shows the minus I effect. All are shows the minus I effect like that. Okay, so here the minus I effect is increase the stability of carbanion. So the distance between minus I group and negative charge is decrease, stability is increase. So when compare the we can express same example based on the electronegativity. So more electronegativity, more stability of carbanion. So when compare the oxygen and nitrogen, oxygen is more electronegative atom. So when I compare the first and fifth structure, in the first and fifth structure, the oxygen and nitrogen present at the same position. So when I take the order of their stability, first structure is more stable than fifth one. Okay. After when you compare fourth structure. In the fourth structure, the distance between a electronegative atom nitrogen to minus charge is 1 carbon. In the second and third structure, we have a in the second structure and fourth structure, oxygen and nitrogen are present at same position. Both are differ by negative charge by 1 carbon atom due to high electronegativity. Here also second structure is more stable than fourth structure, and third structure is at last. Why? Because here in the third structure we have two carbons differ between negative charge and highest electronegative atom. So this is the order of their stability. Here order of their stability we expressed based on the electronegativity. More electronegativity, more minus I power, then more stability of carbanion. Okay, so this is next example. So this is example 4. Here we have again 4 structures. In these structures all are benzyl carbanions and substituted benzyl carbanions. So in the first structure, NO2 group at para ortho position. So NO2 group shows minus IM effect, and in the second structure, NO2 group present at meta position. Here it can show the minus I effect. In the third structure, NO2 present at para position. It can show the minus M effect, and it is benzyl carbanion. It is a reference structure. So when you observe that the minus M effect and minus I effect are is directly proportional to is directly proportional to stability of carbanions. So if we take the order of their stability, here minus M effect, minus effects are more effectiveness in ortho position. So first structure is more stable than third structure due to minus I effect, and in the second fourth structure, in the second structure NO2 shows the minus I effect. So next priority for minus I effect, and at last for a reference structure. So this is the order of priority of given 4 structures. And next one, example 5. Here also we have 4 structures, and we have methyl groups at ortho, para, meta and para position of benzyl carbanion, and here we have benzyl carbanion as a reference structure. So when you see this, here methyl group shows the plus I effect at ortho position, meta position and para position, and it is a reference structure. So when you observe that at the same time plus methyl groups are taken as a plus M groups also due to electron releasing capability. So here when you compare the plus M effect or minus I effect can be decrease the stability of carbanion. So when you take the order of stability, here reference structure is a more stable structure due to absence of any plus I groups. Plus I group or plus M group destabilize the or decrease the stability of carbanion. So due to that reference structure is more stable. After that second structure is more stable. Why? Because in the first and third structure both plus I and plus M effect is operated. Plus M effect is more effectiveness than plus I effect. That's why second structure is more stable. After when compare the first and third structure at ortho position, the plus I effect and plus M effect is very effectiveness when compared to the para position. That's why next highest stability is third structure, and first structure is at last. So this is the order of stability of these 4 structures. And next example, so when you go for next example, this is third example. Here also we have 4 compounds. Here we get methoxy groups in place of methyl groups. So orthomethoxy benzylanion meta para substituted, and it is reference structure. So here methoxy group shows both plus M and minus I effect. Here only minus I effect. Here plus M and minus I effect, and it is a reference structure. When you take the order of stability, plus M effect can be destabilized. So that's why second structure is more effective than remaining one. After second structure, second structure, first structure here minus I effect also can operated. So first structure is more stable. After third structure is more stable, and fourth structure is at last reference structure. Okay, this is their order of stability. Okay, and this is the last example. It is very big one, so you must be well focus on it. So here we have 10 structures is there. All are substituted of benzyl carbanion. So if you observe one by one, in the first structure we have NO2 group, it is minus M group, aldehyde minus M group, chlorine plus M, bromine plus M, alcohol plus M NH2 plus M methoxy plus M methyl plus I, it is reference, and Cn is minus M. So here we have more plus M groups and minus M groups at same position. If we take the order of plus M power and minus M power, so first I just take the order of plus M power. So why? Because plus M power can be destabilized. In plus M power we have chlorine, bromine, alcohol, amine, methoxy groups. In all this NH2 having more plus M power. After that methoxy more plus M power. After OH group, after chlorine, after bromine. This is the order of plus M power. So the stability of carbanion is quite opposite to this order. Suppose bromine is least plus M power and it is more stable in the carbanions having plus M groups. At the same time, if we take the minus M power, order of minus M power, here we have 3 minus M groups, NO2, CHO and Cn. NO2 is more minus M power after Cn, after CHO. So based on this, if we take the order of their stability, okay, the order of their stability is highest one is first structure, after structure 10, after second structure due to high electronegative groups. After that we get the reference structure. Sorry. After that we get reference structures. Why? Because here no plus I or plus M groups are present. So next one is reference structure. After that we will take the plus I group. Why? Because plus M group is more effective than plus I group. So next position is methyl paramethyl benzyl carbanion. After that we need to take the remaining compounds. In the plus M power, bromine is at least, so it is next position. After chlorine, after alcohol, after methoxy, seventh structure, and at last is amine, sixth structure. So this is the order of stability of given compounds. Okay students, if you like my concept, please subscribe to my channel. Please like and share my videos. Thank you.